the talk is entitled Percival Lowell and the Canals of Mars. And what I'm going to do is tell you about some of the, just a bit about some of the very early observations of Mars, and then, something about Percival Lowell, who essentially built up an industry around the canals of Mars that obviously sparked a lot of interest. And you mentioned earlier on about a lot of the films that have been done about Mars. Well, in his own way, Lowell was round about the same time as people like H.G. Wells, who were writing about Mars, and surely his ideas must have influenced Wells. Anyway, so just a few words about Mars, which is currently gracing the early morning sky, but will come to opposition later this year, round about Christmas time, I believe. But as I'm sure everyone here knows, Mars is only about half the size of Earth. Its orbit is more eccentric than that of Earth. And so that means that there's sort of quite a big distance between perihelion and aphelion, about 206 million kilometres when Mars is closest to the Sun, and 249 when it's furthest away. And its orbital period is 687 days. And so just a little diagram showing that, of course. Oppositions of Mars occur every 780 days. Opposition when the Earth lies directly between the Sun and the planet. And because of the big or the large distance between perihelion and aphelion, it means that some oppositions are far more favourable than others. A favourable one would occur when Mars was at perihelion. So at opposition, a perihelic opposition, the most sort of favourable distance is about 56 million kilometres, but it can be nearly double that when Mars is at aphelion. So particularly favourable oppositions were in 1877 and 2003, which I'm sure a lot of people will remember. And there's a photograph of Mars in the evening sky, which I've shamelessly sort of cut and pasted from somewhere, and I can't remember now where I got it from, but there you go. So once the telescope had been invented and was being used for astronomical purposes, then Mars was obviously one of the objects that astronomers wanted to look at. But because it is a fairly small disk, and the early telescopes were quite crude, then we didn't really learn too much. For instance, there was Fontana. He made a crude drawing of Mars with what he described as a pill black dot, but then he saw the same feature on Venus. So I think we must put that down to a telescope defect. But as instrumentation improved somewhat, people started to see patches on the disk. So Father Bartoli was one of the first to report these, and two sort of fairly famous observers, Riccioli and Grimaldi, also saw similar features in the middle of the 17th century. But I suppose really the first great advancement was when this man came along, one of the all-time greats of science, Christiaan Huygens. And in 1659, on November the 28th, Huygens made a drawing like this, where he saw patches and a V-shaped feature on Mars, which we would now identify as the Syrtis Major. Now, what he also did was, by lining up this V-shaped feature with the on the central meridian, I suppose we'd call it now, and measuring the time it took for that feature to sort of come back to the same position, he was able to measure the rotation period. And he said the rotation of Mars, like that of the Earth, seems to have a period of 24 hours. And in 1672, he also noticed that there was a south polar cap, a white patch on Mars. And then a bit later on comes along another one of the greats of the time, Cassini. One thing that Cassini did use Mars for was to measure its sort of parallax against the background stars, because in the 17th century, one thing people were trying to do was get some idea about the scale of the solar system, the distance of the planets. And Kepler's laws obviously were well established by then. The link between the orbital period of a planet and its mean distance from the sun. Kepler had worked that out from the maths of the orbits, the maths of the ellipse. But the problem was that distances to none of the planets had been measured then. So, you know, the idea being that if you could get an accurate determination of the distance to one of the planets, provided you knew its orbital period, and these were well known, you could work out the distance of other planets. And so what Cassini did, he was observing from Paris, and he sent his assistant to South America, and they were able to establish that the distance between the Earth and Mars was now about what we would call now about half of an astronomical unit. And his estimation, you know, wasn't at all bad. Later on, people would go on to refine it, particularly using, you know, transits of Venus. But because Mars was so, you know, prominent in the sky the year that they did this, then, and also you had to know the distance between Paris and Cayenne in South America. But that was known, and they were able to measure the position of Mars from South America and from Paris against the background stars, and then use a bit of trigonometry to work out a distance to Mars. So Mars was important from that point of view. So he measured the Earth-Mars distance, and he was able to calculate the Earth-Sun distance as being 87 million miles, about 140 million kilometers. And now, of course, you know, we know it's about 93 million miles or 150 million kilometers, but that's not bad, is it, what Cassini came up with? But he also measured the rotation period, because he'd seen features on Mars like the Syrtis Major, and he came up with the rotation period of 24 hours and 40 minutes. Now, Huygens' earlier results, for some reason, were never published, and so Cassini's determination was completely independent, is in very good agreement with the, you know, the modern accepted value, which is slightly less than this. Now, around the same time in the 17th, 18th century, other people of repute were looking at Mars, people like Robert Hooke, Maraldi, who was Cassini's nephew. He made several observations of the Martian poles, these whitish spots that were there. William Herschel spotted the polar caps with dark markings on Mars and made an estimate of the diameter of Mars. And other well-known observers at the time, Schroeter, Baron Mardler, William Dawes, also trying to make fairly crude maps of Mars from observations that they've made. But we're going to jump forward a bit to this man, whose name I think is forever linked with that of Lowell, and this is Giovanni Schiaparelli. Now, what do we know about him? Well, he was born in 1835, and he'd studied engineering, but he'd also taught astronomy and maths. And his local government in Italy was anxious to sort of train people up in astronomy. So he got a stipend from the local government to do further study in astronomy. And he worked with people like Encke in Berlin and Struve at Pulkowa in Russia. So he was getting some very good teachers there. But he did go back to Italy, and he became director of the Brera Observatory in Milan in 1862. One important piece of work that Schiaparelli did, excuse me, was that he was able to show the connection between meteor showers and comets. You know, something we take for granted these days, but you know, someone had to sort of work out what this was. So Schiaparelli was a bit of a pioneer here. Now, the observatory in Milan was equipped with a 22 centimetre, just over 8.5 inch refractor. And, you know, this was a new instrument that was put in when Schiaparelli took over as the director. And he was interested in various areas of astronomy, not just meteor showers, but also double stars. He made thousands of measurements over 25 years. but he was also interested in the planets, and using a nice telescope, you know, like this, then, you know, the planets would have been good targets. Now, 1877 was the year of a very favourable observatory. Favourable opposition, sorry. And so what better, you know, to point your nice telescope at than Mars. And there's a picture of the telescope there. I don't know whether it still exists or not, or whether it's still there, or maybe it's in a museum. I really don't know, but it certainly was a nice instrument. So Mars, then, there was this very close opposition, 1877. And using the telescope, Schiaparelli was able to make some maps of Mars, and he named some of the features after terrestrial lands and seas. Others were named from mythology. But, you know, it's quite difficult to make out some of these features because the seeing wasn't always very good. But occasionally he wrote that small details flashed out at him from time to time. And he wrote that there were moments of absolute atmospheric calm. It seemed as if a veil were removed from the surface of a planet, which appeared like a complex embroidery of many colours. And this fine detail that he was referring to were linear features, and he called them canali. Okay, and now in Italian, canali means channels or canals. It can mean either, apparently. And you know, Schiaparelli meant that what he was observing were natural features, which I think in English we would call more of a channel. But unfortunately, canal was adopted in English with some far-reaching consequences, because the word canal implies something that's built, something of artificial origin. Now, this was one of his maps, his 1877 map. There's his, you know, obviously his grid that he used. So he's got a southern sea up here, Mare Australe. There are various other features, seas that he saw there. And yeah, so we've got an ocean there as well. So as I said, a lot of these features were named after terrestrial features. But this was another one of his maps. And this, I think, better shows these linear features, or canali. So again, there's your southern sea up there, and various other seas, and then this network of fine lines that were crisscrossing the planet. Now, as far as I'm aware, other than sort of drawing them and naming these features, I don't think that Schiaparelli actually, you know, sought out any explanation for these. And there's a colour drawing there that he made. And these are just some pages from his notebook there. So these drawings that he made weren't just on the basis of sort of one or two observations. He did make multiple ones. And he not only observed at the 1877 opposition, but at subsequent oppositions too. And this is where this man, then, we're going to start talking about him now, Percival Lowell, who lived between 1855 and 1916. So there's a picture of him there. And there's a picture of him on the right-hand side with one of his younger brothers. The Lowells were a family who lived in Boston, Massachusetts. Some of their ancestors had gone over with some of the early settlers in the US, and the Lowells were a very wealthy and influential family in Boston. They were part of what were called the Boston Brahmin, you know, upper class, wealthy, intellectual people. And so, yeah, so he was born in March 1855. His parents were Augustus and Catherine Bigelow Lowell. Catherine's parents had been involved in, I suppose you'd call it diplomacy these days. They'd been, they actually lived in London. You know, as I said, we'd call them diplomats, I think. But they were a very wealthy, influential family. And the family's fortune came from cotton mills, because, and I think or been to visit Manchester to see a lot of the sort of technology there. but they're also involved in things like real estate, water. You know, they're expanding into all sorts of areas. Yes. But in addition to sort of Percival, his other brothers and sisters, some of them also went on to be very prominent. One of his brothers, Lawrence, became president of Harvard University, and one of his sisters was Amy Lowell, who was an important poet. And there's Amy Lowell there in 1922. And she got on the cover of Time magazine, which I don't think they let anyone on the cover of that, do they? But as I said, she did write poems. So if you are interested in poetry, these are some of hers. There's this one here, or a collection called The Songs of the Pueblo Indians, the basket dance. Dance, dance. The priest is yellow with sunflower meal. He is yellow with cornmeal. He is yellow as the sun, and so on. I'm sure if you want to read these, you can look them up yourself. But she was a very prominent poet. So I think, you know, growing up in the Lowell household, there must have been some sort of very interesting conversations. And also perhaps if they congregated together in later life, you know, talking about, you know, a day at Harvard University or a day writing a poem or something like that. And Lowell himself, when in his sort of later life, he's got a very charismatic personality. Someone said that, you know, being in the same room as him, it was if one had suddenly been deposited in a powerful magnetic field. He could hold people's attention. Because, you know, the family was wealthy, he was educated in private schools, very proficient in all subjects. He was fluent in French by the age of 10. At the age of 11, apparently, he wrote 100 lines of Latin verse on the loss of a toy boat. The family home was called 7 L's because there were 7 Lowells, 7 L's living there, and there was a telescope on the roof. That's a picture of, I suppose, you know, the sort of 19th century, you know, photograph of the house. But a few years ago, I think it was 2014, if you'd got about $4.5 million, you could have had that house because it came up for sale. And this was a picture I found on the internet. That does look rather nice, doesn't it? You can imagine yourself walking down that staircase, can't you? And, you know, these wealthy and influential Lowells walking down the staircase to welcome their guests. I assume it was sold then. If it comes on the market again, I'll let you know. But yeah, very nice. Okay. Lowell himself went to Harvard. To get into Harvard, he actually had to write an essay, and I think it was on the foreign policy of Elizabeth I. So an incredibly well-rounded man, and he actually graduated in mathematics. After his graduation, he did what a lot of you know, young men at the time did, well, wealthy men anyway. He did the grand tour of Europe. You know, going around making connections. And then when he went back home, he worked in the family business for 6 years. But he'd always harbored an interest in the Far East, in China, and particularly Japan and Korea. And he was quite worried because, you know, at the time, you know, Japan was starting to sort of open up a bit to the West. And he wanted to go to Japan and do what he could to try and preserve Japanese culture, you know, from being modernized too quickly. So he did spend, you know, quite a few years, about 10 years in the Far East, in Japan and Korea. It's, again, his role there isn't entirely clear. Some sources say that he was involved in sort of trade, you know, delegations, but maybe that was in, you know, contrary to sort of preserving the Japanese culture, if he's trying to open up trade talks. But he did, you know, learn the languages and lived, you know, the sort of local life. So that's him there. I think that's with people from, I think it said the Korean embassy. And you know, more of his Korean and Japanese friends, okay. And he wrote books on the Far East. He wrote Chosun, which is Korea, The Land of the Morning Calm. He wrote a book, The Soul of the Far East, and on Hidden Japan, so he was producing these books, but all the time that he was in the Far East, he was keeping his interest in astronomy. He had taken a telescope with him. And of course, he was, getting reports, books sent to him about what was going on in the world of astronomy. And he was particularly fascinated by the world of Schiaparelli, these linear features, these canali that were being seen. And he was actually had an astronomical encyclopedia that listed the dates of the oppositions of Mars. And by the time he was reading this, the 1894 opposition, and he said to have written in the margin of this book, "Hurry," because he wanted to go and observe this. And he realized that the best place to do this would obviously be to go back home. So he started up some correspondence with William Pickering. Pickering was one of the two Pickering brothers. Edward Pickering went on to become director of the Harvard College Observatory. And in fact, by that time, he would have been director of the Harvard College Observatory. So William, his brother, would have been a good person to talk to. So obviously, Lowell had got lots of money, so he could, finance expeditions by various people to go and test out sites. Now, Pickering suggested to Lowell that probably the best place to go and look at Mars, carry out some observations, was somewhere like Arizona, the Arizona Territory, as it was then. I don't believe it was a state. So, financed by Lowell, Pickering arranged for one of his assistants, Andrew Ellicott Douglas, to go to Arizona with Lowell's 6-inch telescope. And the idea was that they test the seeing at various locations. Lowell had said he wanted to build an observatory to observe Mars. So he obviously wanted the best location for it. And this is Andrew Ellicott Douglas there. And you may be wondering, why has he got that? Why is he standing by that big tree trunk? Well, amongst his other interests, apart from astronomy, Douglas was actually interested in trees, and he was really one of the founders of what we call dendrochronology, using tree rings to date various events, get the ages of trees. And you can see that Douglas lived a very long life. Okay, so Douglas has set off towards Arizona with a telescope, and eventually a site near Flagstaff was chosen. And so, there are plans afoot to sort of, start the building of the observatory, hire staff, get some telescopes there. And in fact, it was agreed that probably one of the foremost telescope builders of the 19th century in the US, Alvin Clark, would build the instruments. Remember that as far as Lowell's concerned, money is no object. And Douglas remained in Flagstaff for the winter. And the region that was chosen to build the telescope was called Mars Hill. Now, unfortunately, though, it became clear that winters in Flagstaff weren't, perhaps always ideal. And here's a picture of two handymen that were employed by the observatory, Edward Mills on the left there and Stanley Sykes on the right. Sykes is actually quite an interesting person because he and his brother, they'd emigrated to Arizona from Britain. And in fact, I think their father had actually been a bit of a photographer and had taken some photographs of Queen Victoria. But when Sykes and his brother got to Arizona, they actually opened up a repair shop for things like bicycles. But, they're very handy people, very good with their hands. And so they came to get a job at the observatory workshop. Now, Sykes was there for this early winter on Mars Hill. And, it wasn't looking good after the winter there, because Sykes developed his own scale of seeing on the basis of what he'd experienced. Okay, so the Stanley Sykes scale of seeing on Flagstaff was 10 when you can see the moon, 5 when you can still see the telescope, but 1 when you can only feel the telescope but not see it. Okay, so the winter up there was pretty savage. So this was a great disappointment for everyone. And so Lowell said, well, we can't have this. Let's move somewhere else. Let's go to Mexico. So a site at a place called Tacubaya was chosen as a new site for the observatory. And being a bit further south, the opposition would be seen better from there. The 1896 one, Mars would be a bit higher in the sky. And Lowell arrived round about the time of the opposition, but it didn't really turn out to be much better than Flagstaff. You know, seeing wasn't that good. And also Mexico was less politically stable than the US. So by April of 1897, everyone had moved back to Flagstaff, and that's where they remained. And Lowell's aims with his new observatory was that he wanted to study the solar system, because he said there is strong reason to believe that we are on the eve of pretty definite discovery in the matter. Now, what was he talking about? Well, we'll see. He said that speculation has been singularly fruitful as to what these markings on our next to nearest neighbour in space may mean. Each astronomer holds a different pet theory on the subject and pooh-poohs those of all the others. Well, that was certainly a true statement. But this is where this is what Lowell said. He said, the most self-evident explanation from the markings themselves is probably the true one, namely that we are looking upon the result of the work of some sort of intelligent beings. The amazing blue network on Mars hints that one planet beside our own is actively inhabited now. And there's Lowell looking through his telescope. I think that was the Clark refractor. And like Schiaparelli, Lowell started to map Mars. And he was seeing these features crisscrossing the planet. And sometimes the features seem to be double. And he called this gemination. So you've got a double set of lines there. And Lowell came up with this idea that these canals, as he called them, were built by a dying civilization. And the canals were built to take water from the ice caps, which he believed to be water, to the arid equatorial regions. And, you know, sometimes he and other observers could see, you know, if you like, what he used to refer to as a wave of darkening going across the planet. And he put this down to the growth of vegetation across the surface of Mars, you know, that vegetation being watered by these canals. And of course, if you look at his maps, then, you know, these canals must have been enormously wide, if the scale's right, and the distance between them would have been very big. But these areas where the canals seem to meet up, he thought that they were like oases on the Earth. So these were the sort of maps that were coming out. And there's another one there, because he did also produce a Mars globe, and I think I've got a picture of that later on. So he was coming up with this idea about this intelligent civilization on Mars. The public really lapped this up. He wrote books about it. He gave lots of lectures about this. And around about 1900, there was a prize on offer to the first astronomer who could detect life on another planet. But so convinced were people at the time that there was life on Mars, that Mars was specifically excluded from the remit of the prize. So again, like Schiaparelli, he made lots and lots of drawings. More that you can get loads of these, you know, off the internet if you want to. And there's the man himself. He actually lived in what was called the baronial mansion on Mars Hill. So he lived up there. And there's another one diagram he made of what, you know, the changes in the polar ice cap, the South Polar ice cap in 1894. There he is again. And he did colour drawings as well. So the red of Mars and these what he perceived as being the greener areas, well, he put that down as being areas where there was you know, high concentration of vegetation. And lots of drawings. Okay, so this is one of the books he wrote, Mars as the Abode of Life. And there's a Mars globe. Okay, and as I said, he was giving lots of lectures, writing these books. But yes, the public were really, you know, lapped up this idea about this intelligent civilization, but others weren't so convinced. Schiaparelli, okay, he said, it's certain that Lowell commands superior means to any other hitherto employed on Mars. I mean, Lowell's telescope was much better than Schiaparelli's, but he said, if his perseverance and enthusiasm do not desert him, he will make considerable contributions. On the other hand, he needs more experience and must rein in his imagination. So a bit of a warning sign there. And although, yes, I mean, there were other astronomers who were seeing canals, but there were others who couldn't, who didn't see them. And these included some of the greatest observers of the time, Edward Emerson Barnard in the US and E.M. Antoniadi in France. And I mean, Antoniadi, you know, made observations of Mars and Mercury. They couldn't see any of these canals that Lowell was finding. So, and in fact, much later on, Carl Sagan, he always, in one of his lectures, he used Lowell's example of an overproductive mind as a cautionary tale about the power of belief and yearning to trump science and reason, because he said Lowell was, unfortunately, one of the worst draftsmen who ever sat down at the telescope, and the kind of Mars he drew was composed of little polygonal blocks connected by a multitude of straight lines. Okay, but it's ironic that Lowell is sometimes compared to Sagan himself, because in a paper that was published in 2007, the authors of Space Science Reviews described Percival Lowell as the most influential popularizer of planetary science in America before Sagan. And that's probably true, but obviously Sagan was you know, putting forward a more scientific view, whereas I think it's true what both Schiaparelli said and Sagan said about Lowell, that he let his imagination and enthusiasm, you know, carry him away, not with some, of course. But so what were the canals then? I mean, I'm not sure, is this working? Yes, it is, I think, isn't it? Maybe, you know, some sort of optical illusion. What he was doing was he was stopping his telescopes down, and you know, obviously there was a lot of sort of eye strain going on there. And we know that, I'm not sure if this is working. It worked before. Can you see these little things? If you look at them, they should actually appear to rotate, but I'm not convinced.
They are. It's quite mystifying.
Yeah, they are. But again, that they're not rotating. It's your eye and brain, isn't it? Okay. Oh yeah, I can see it. I can see it now, actually. Yes, I was probably just getting a bit nervous that they weren't doing anything. So, you know, some sort of optical illusion. But in more recent years, people have come up with another an explanation for the canals, because in addition to observing Mars, Lowell observed other planets, including Venus, and he was observing Venus under similar conditions to how he was observing Mars, and his diagrams of Venus include what are called spokes. So on the right hand side here, these you know, like black lines. It's more like a spider to me, actually. I think it was a spider caught somewhere in the telescope, but no, it was there. So what was this? Well, on the left-hand side here, we've got a photograph of an eye, okay, the back of the human eye. And some people, again, these are ophthalmologists and scientists, because Lowell was really, stopping the telescope down. So he'd got a very small exit pupil, and various, as I said, experts have said that a small exit pupil often casts shadows of blood vessels on the retina, making them visible. Okay, so as the eye pupil moves with respect to the small telescope pinhole, the angle at which the rays arrive at the retina changes. So that feature can result in these shadows. So what some people have suggested is that canals, like the spokes of Venus, were actually, if you like, the pattern of blood vessels on the back of Lowell and indeed other observers' retina. So that's a very interesting point there. So he was mapping the structures in his own eye, essentially. But that's a sort of the latest theory. Anyway, Lowell was a very hard worker. He'd got this punishing, timetable. He was lecturing, he was writing, he was observing. And remember, he had to move the telescopes to Mexico for a while. But all the time, he was subject to criticism. The public adored him, but we've seen people like Barnard, Antoniadi, and other observers. They weren't convinced about these canals at all. And it led to him having a nervous breakdown. So he took a break from the observatory. And while he was on sick leave, this man here, Thomas C, TJJC, took over as the interim director. But this was not a good move for the observatory. He was extremely arrogant, whereas that was not the case with Lowell. Lowell, his employees held a great deal of respect and loyalty to him, but not, C came in and in the end he was fired for his attitude towards the staff. So when Lowell did go back, obviously there was pleased to see him, but there was a lot of sort of bridge building to take place. But what about Andrew Douglas as well? Now, he initially, as I said, he served as a junior to Lowell at Flagstaff. And to begin with, he supported his views on the Martian canals. But in 1887, he became acting director and started experimenting with artificial planet discs. So what he was doing was, making discs, placing them some, way from the telescopes and looking through them and getting people, including himself, to draw what they saw. And his results led him to question some of Lowell's assertions, because again, it was appearing that what people were seeing weren't genuine, phenomena. It was, something to do with the eye, an optical illusion or whatever. Now, because he questioned Lowell's views, he was dismissed from his post, but he did go on to found the Stewart Observatory. And as I said before, he was one of the early pioneers of dendrochronology. Now, at the observatory, it wasn't all serious work. The observatory had got its own cow to supply milk. The cow was called Venus. So this is Venus on Mars. And there's Venus again. I mean, I've never been to the Lowell Observatory. I don't know if anyone here has. So, it'd be interesting to find that after the talk, if anyone has been. But as I said, Lowell's had got lots of money, and he'd got this car here. I'm afraid that name means absolutely nothing to me. Again, there may be car enthusiasts who might be drooling over one of these. I've no idea. But it's a nice bright red. That's all I notice about it. But it does look rather flash for the time. Again, showing the sort of money he'd got. Well, as I said, Lowell did have quite a number of faithful staff there. And one of them was this man called Carl Lampland. And Lampland was very interested in photography. Now, the observations that Lowell and a lot of others had made were reported in the form of drawings. And a drawing is quite subjective, isn't it? You can draw what you want to be there, but a photograph surely is a far more definitive piece of evidence. And so Lampland started to experiment with taking photographs of Mars. And he did produce some photographs, which, according to Lowell and to Lampland, did actually show the canals of Mars. But again, a lot of other people weren't convinced. So, if Lowell had been hoping that photography was going to save his canals, he was disappointed. Now, Lowell actually married quite late in life. He married this lady called Constance Savage Keith. Well, Lowell, when she got married. And there's, she came from, again, quite a wealthy family of her own. And, but Lowell had also, for some years, had, well, I don't know, it's a bit difficult to tell what was going on, but he'd had a great friendship with this lady, Wrexie Louise Leonard, who acted as his secretary. And there's a lot of correspondence between them, very fond correspondence. And she also lived in the baronial mansion, separately from him. But, it was, people often questioned why he didn't marry her. And the answer that was, someone has suggested is that Bostonians did not marry their secretary. So maybe there's a bit of a class thing going on here. But she was a very faithful, secretary to him. And she also, took part in some of the observations, as you can see there. And, well, his marriage to Constance, they weren't married for all that long, actually, before he died. And when they were on their honeymoon, they actually came to London and they went in a trip on a hot air balloon above the capital, which must have been quite something. Okay, there they are there. And Constance didn't actually die until 1954, so she survived him by quite some time. Lowell himself died in 1916, and he is his mausoleum is at the observatory, so that's his mausoleum there. And this is, I think this is Comet Hale Bop above the Lowell Observatory. Now, sorry, can you just look at the next slide? Okay, I'll come back to that in a minute. Okay. Okay. When he died, he left money in his will to Constance, but he also left money for the upkeep of the observatory. Now, Constance wasn't at all happy about this, and it led to a long period, going through the courts. And in the end, I think they probably paid out more in lawyers' fees than than Constance actually made out of it. But as soon as Lowell died, one of Constance's first acts was to sack Wrexie Leonard. Now, it's quite I don't know, perhaps some years later, Wrexie Leonard wrote a book about her time at the observatory, and about Lowell himself and the other people there, and also about Constance Savage. Now, remember that her name was Constance Savage Lowell. Well, in the book, Wrexie refers to her as Lowell Savage Constance. And, is it just a coincidence that Constance Savage Lowell's initials were reversed? Or is Wrexie trying to get some sort of revenge here by calling her Savage Constance? Okay, so we shall see, okay. But, as I said, she did fight for every penny that she could get out. But nevertheless, there was enough there to keep the Lowell Observatory going for, some years. And although, perhaps people these days, they think, oh, Percival Lowell, Canals of Mars, I think we should also remember that he did found one of the world's great observatories. And if I've just got a tiny bit more time, what I'll just say something is about Planet X. Now, I think throughout astronomy, Planet X has meant different things, okay? But in the time of Lowell, X meant a planet beyond Neptune. And this was something that Lowell was very interested in. And a photographic search for Planet X was begun as early as 1905. And Lowell himself was very involved in this, and he carried on with it until a few months before his death. Okay, and of course we all know now that it was at the Lowell Observatory, founded by Lowell himself, that Pluto was discovered by Clyde Tombaugh in 1930. So I think that's quite nice that it took some time to find it, but it was found at his observatory. And this was I probably can't read that very well, but this was the observation circular, the discovery of a solar system body apparently trans-Neptunian. And you can see down the bottom there, Flagstaff, Arizona, March 1930, and VM Slipher, Vesto Slipher. The two Slipher brothers, Vesto and Earl Slipher, were also working at the Lowell Observatory, and they would have known Percival Lowell himself. So that's the man himself there. So he was able to found this observatory because of his immense wealth, but also because of his passion and his drive and his enthusiasm for looking at the planet Mars. And, we now know, Mars is a very well mapped planet from orbiting spacecraft. We now know that, there seems to be no, correlation between any of the linear features that people like Lowell and Schiaparelli mapped. But then if they were drawing the blood vessels at the back of their eyes, it's no wonder, is it? But, there's no doubt that he did give, planetary exploration a real boost, and got the public really excited by this. So I'll finish there about Percival Lowell. So I hope you've enjoyed it. If you want to find out more about him, I'll just stop sharing there. Then there is a biography of him that was written, I think, about in the 1920s or 1930s by his brother Lawrence, who was the president of the Harvard Observatory, and you can get a copy of that. It's been scanned and put on the internet, but also the book by Wrexie Leonard about Lowell and the other people who worked at the observatory, and her rather savage Constance remark. You can get that as well. So there's a lot there. So I hope you found that interesting, and thank you very much for your attention.